Yes. Good afternoon, everyone. So my name is Michael Okoko. I currently maintain MongoDB exporter. So it's like the major open source exporter, Prometheus exporter for MongoDB. It's part of my day-to-day job at Percona, but aside that, I also work on GoWager. So GoWager is a prediction market. I do a bunch of things there: engineering, support, infra, and all of that. But this talk is again about MongoDB and what happened there. So it's like a war story. So some backstory: MongoDB Exporter, like I said, it's the main monitoring solution, open source monitoring solution for MongoDB. So if you don't want to, use the monitoring that comes with Atlas, and you're running MongoDB maybe in your own Kubernetes cluster or you are self-hosting somewhere on AWS, you would use our exporter to tell you how your database is performing. Now, the way most people run MongoDB is that they put it in a Kubernetes cluster, right? And sometime around late last year, we shipped support for a backup tool called Percona backup for MongoDB. And that thing, the bug from that gave us so much issues that...
Full screen. We want your distance to be full screen.
Oh, okay, sorry.
Move to the next side. I want you to be full screen. Like, what are you, how you...
Oh, okay.
It's like it's these borders I show us with your victim.
Oh, I don't...
Just go to your side. You don't need your speaker notes, right? Okay.
Yeah, so back to it, right? The exporter is supposed to tell people, when their database is acting up, when memory usage has spiked, and all of that. And then all of a sudden, we have this bug where something that was supposed to monitor other things is now crashing. So there was no way for users to know when their database is down, for example, or when they have too many connections in their database, right? And this is what the graph looks like. So the way an OOM-Kill works is that when you have, like, you set a memory limit, right? It's like your RAM, but then you don't want your application to use all of your RAM. And so what happens is you set a limit, let's say 1 gig, and when the application hits that limit, the container gets killed, or when it crosses that limit, rather. And so what we see here is that when the application starts, that is when the exporter starts, it starts to go up, the memory usage starts to go up, it gets to a point, it gets killed, and then it drops back, right? And then it's restarted again. It goes up, gets killed, come down, and we are seeing this pattern over and over again. You can see some kind of minor droughts. That's usually because of garbage collection. Golang would free some memory, but it's not enough to, caution the entire effect. And when you are having OOM-Kills, I mean, this is what the graphs look like generally. The next step for us was to now try to reproduce this locally and see what it looks like. And I mean, locally we see the same behavior. It's just that, on your local machine, for example, you're not going to get OOM-Killed, right? You have maybe like 64. We have laptops with 32 gigs of RAM, 64 gigs of RAM. So it might not get killed, but you see this usage go up. And if you run this for a long enough time, currently it's at 50 MIB. Well, if you run this for a long enough time, your laptop will just crash, right? And this brings us to one of the more important metrics when you are monitoring Golang applications, which is the heap in use bytes. So you can see the metric we are tracking up there. It's actually useful to understand how much memory application is using at a specific time. Now, enter pprof. So pprof is something that comes with Golang. What it does is it gives you some sort of insight into what your application is doing. So you could say, oh, you want to look at how much CPU your application is using, right? What that means is it's going to profile your CPU, and then at different intervals it looks at, okay, what function is currently running on the CPU. It does that I think like 100 times per second, and at the end of the day it gives you like this nice visualization of what application spent the most time on the CPU. That's for the CPU profile. Same thing for Go routines. If you have, let's say you are leaking Go routines, right? You could use the Go routine profile. Then there's allocations and heap. There are more of them actually, but for me, like day to day, this would be like the ones I interface with for the most part. Two of those profiles are related to memory. So we have heap allocations and then allocs. A logs is like a history, right? You have your application, it uses memory, it frees it, it uses memory, it frees it. A logs give you that history of, again, how much memory your application used. But for heap, it takes the point in time allocation. So that is, when you take a heap profile, you are looking at what application is currently in memory. And when you're debugging an OOM-Kill, typically that's what you want, right? Because you want to look at what application was in memory by the time your application was killed, basically by the time your application crashed. And then again, pprof has like this the visualization I was talking about. So essentially, what happens here, I don't know how clear it is from there, but essentially what it does is it gives you like function calls. So you have each function, and then you see how much memory the function was using, and those functions call other functions. Right? So it's like a stack, and you can see the memory it's using as it goes down. So if you have a function calling some other function, then you can see the memory that each of them were using at the time, and it expresses it as a percentage of the overall application. So this is just a sample. Soon we'll look at how to navigate this. But aside that visualization, there's something called flame graphs. Some of you might be familiar with it. Flame graphs are essentially the same thing as the other visualization we saw. It's just that it presents it like some sort of error key, where you can see, okay, for this parent, the child took this X amount of time, and then for that child, the next child took, some amount of time. And it's just a nice way to see your application behavior, right? Because, yeah, it's like you get to see what function is taking the most time or using the most memory, essentially. Now, again, still on pprof, what happens is, with Golang, it's very easy. It's very straightforward to profile applications. I think you import net pprof or something like that, and that's just it. You don't need to do anything special. And it's important to do this even in production, because for some people, they feel like, you enable pprof, it's going to, take a performance overhead, or your application is going to take a performance hit. But that's usually not the case. I think of it like logging. So if you're not logging in your application and something happens, you just get lost, right? So in this case, you want to profile why your application is running in production. And the helpful thing is that way, when things like this happen, you're able to just, point call at it, or point go to pprof at it, and, get your profiles. So for us, what we did was, when this thing, like we've been able to reproduce it locally, now what we need to do is see how it looks like, right? So at point A, we take a profile, we see, okay, at this point, what applications or what functions are actually in memory. We give it some time, and then we try to take another profile. And in this case, it was like 30 minutes. And this is what that looks like. So here we see the visualization I was talking about. And if I try to zoom into it a bit, we see the function that was taking the most time. So you can see it right here. It's called topology server update. It's taking like 30% of memory, right? This was, how do I say it? This was a short profile. It was like 30 minutes. So in our case, the memory usage was not a lot, but we see that it's still taking a large chunk of the time. Not like in that cluster environment where it was using, like 1 gig of memory. That one was running for a longer time. But essentially what happens here is that pprof gives us a way to now see how the functions are getting called. So we see the main function at the top, that is the culprit, but everything below that is red, right? And then you try to trace it down. So what happens is, at the top level, you see some 4.97 MB being used, and that is then shared across these 3 children, right? They are all using, like different levels of memory, but this basically goes up and down. And it gets a bit complicated, because essentially what we are seeing here is that the exporter is trying to create a connection over and over again. So it's like, for that 512 kilobytes of memory, most of them were basically spent on creating connections. For some keen people, you would see that, yes, at this point, we were definitely leaking connections, because if you think about the way you write applications, your application starts, you try to connect to a database, right? you keep that connection open and every instance uses it. So whenever you need your application to make a database call, you just use that connection. You don't try to create a database connection for every function call, right? Because that's going to take a hit. But that was what we were doing in this case. So it was like at every script or every time Prometheus was trying to get metrics, we were trying to create a new connection. But even worse, we were not closing the connection after the script. So it was a case of you open something, the next time a request comes in, you create a new one, but the ones you've opened previously were still opened, right? You're not using it, you're abandoning them. And that is what is happening here. So as we go down again, sorry, I can't exactly use one hand to navigate this, but essentially that's what we have here. So we see like this new connection config, and everything here basically was related to trying to create connections. Again, like I said, I'm not a fan of like this interface, and so I have like this other one that I like to use. It's called pprof.me. It's a website from I think Polar Signals. What they do is they take that complex thing that we just looked at and they express it into this nice flame graph. So what happens here is that when you pick any of the top level bars, again, it's not super clear, but when you pick any of the top level bars, you can try to go into it and then see what that child is doing. So when you pick this, it becomes the new parent, right? And we see the same thing here. So we see that this child function was using most of the memory. We go there, and then somewhere here we see that create connection problem I was talking about. And again and again, and so this new connection config. So essentially what we observed from this was that again, we were leaking connections. It's just that this profile here tells a much nicer story. Now another good thing about the pprof.me that I like is that you get to pick what profile you are looking at. So again, you could be looking at profiles for things that have been garbage collected. What that means is that you are looking at a memory usage, but that's not actually what was there when the crash happened, right? So it gives you like a view of both the memory usage and then the objects. So it's just a lot more nicer than having to use this other SVG. But again, it's in between, right? This one is online. The SVG is something that you could look at offline. Yeah, so again, this would be how you'd visualize. Now, I added this snippet because it was basically the culprit. So we saw memory usage jump from I think like 20 megabytes, like 900 plus megabytes, all because of a single function that was missing. Basically what happened was when we opened the connection, I was saying, oh, we are not closing it, right? And what we were missing was this defect call to close the client connections after the fact. And this is what the result looks like. So you have this memory usage that is spiking, and then after a while, after the fix was applied, it just dropped back, and from there it became very stable. Now, again, takeaways, but before the takeaways, maybe does anyone have any question? All right. So yeah, takeaways. I would say major takeaway would be you should always profile. Profiling is sort of like one of the layers of observability that you should be caring about. Same way you have your logs, right? I mean, most people like logs because it's basically inbuilt, but you should start thinking more about profiling. In production, people would say, oh, like have staging environments, have QA environment, but at the end of the day, your users should be the ones to test for you, no matter how you think about it, because they are going to do things that you didn't think about, or they are going to use your application in ways that you're not thinking about. The third one is fixes can be embarrassing, because again, the exporter is open source. So when these issues started pouring in, people are creating GitHub issues, and started to investigate. We felt embarrassed by the fact that we could miss this kind of thing, but it is what it is. And finally, I would say know your tools. If you don't know about pprof, then there's no way you're going to reach out for it when you encounter something like this in production. So you just need to take that time to explore the tools around whatever stack you are using. And yeah, so finally, thank you.